All right, so let's factor the algebraic expression 21a plus 9. So the first step we're going to want to do is find the greatest common factor. Find greatest common factor here. And in order to do that, we just grab the numbers of the terms. So the number in the first term is 21, so we'll write that down. Whoops. We'll write 21. And then the second number is 9. And then we just have to write their factors. And this is how I know whether a whole number is a factor to the number that we have here on the left. If we can divide, well, I'm going to go from 1 through 10 or 1 through whatever it is. And I'm going to divide those numbers. If any one of those numbers gives me a decimal, it is not a factor. So 21 divided by 1 is obviously doable. It gives us 21. And a factor of 1 is always going to be in each one of these numbers. So we always start with 1 when we find the greatest common factor. Now I ask myself, can 2 be divided by 21? And the answer is it cannot. It will give me a decimal. Can 3 be divided by 21? Yes, it can. So we write down 3. Can 4 be divided by 21? No, it cannot. Can 5 be divided by 21? No, it cannot. Can 6 be divided by 21? No, it cannot. Can 7 be divided by 21? Yes, it can. So I write down the 7. Can 8, 9, 10, 11, no other number, and 21 will be the last factor because 1 times 21 gives me 21. All right, now let's find the factors of 9. Can 9 be divided by 1? Yes, it can, obviously. We can write that down. Can 9 be divided by 2? No, it cannot, so we cannot write down 2. Can 9 be divided by 3? Yes, it can. 9 divided by 3 is 3. Can 9 be divided by 4? No. 5? No. All the way up until 9 itself. And those are the factors. Now, the greatest common factor is the very last one I see that's alike. And obviously here we have 3 to be the last one that is alike. So the greatest common factor is going to be 3. Now, the second step in factoring the algebraic expression is to divide the original expression by 3, the greatest common factor. So that's exactly what we're going to do. So we have 21a divided by 3, which is going to equal to 7a. And then plus 9 divided by 3, which is 3. And we have our simplified or our new expression after dividing by 3. And this new expression is going to be what's inside the parentheses. So we're going to have a parentheses here and have 7a plus 3. And what will go on the outside over here is the greatest common factor itself. Now, how can we verify if this new expression, the factored expression here, is equivalent to the original? Well, we can use the distributive property to verify. So we're going to have 3 times 7a. That's the first number to be multiplied. Then 3 times 3, so plus 3 times 3. And now we just do the multiplication. So 3 times 7a is 21a. Plus 3 times 3, which is 9. So it does verify that 3 parentheses 7a plus 3 is the factored expression of the original. All right, so now let's factor this expression here, negative 18y minus 27. So we're going to write down the first step is to find the greatest common factor. So we're going to write down the numbers of the terms here, 18 and 27. Can 18 be divided by 1? Yes. Can it be divided by 2? Yes. By 3 as well. Not by 4, not by 5, by 6, yes, because 3 times 6 will give me 18. Can 7, 8, and then 9, and then the last one would be 18. Okay, and as well with number 27, the first factor was always going to be 1, obviously. Can 27 be divided by 2? No, it cannot. By 3, yes. 9 times 3 is 27. 4, 5, 6, 7, 8, 9. 9 is the next one. And then 27 itself. Okay. And now I ask myself, which is the last one I see that is common? So the last one I see that's common is the 9. So 9 will be our greatest common factor. And 2 is to divide that greatest common factor to to the original expression that we have. So we're going to have negative 18y minus 27. We're going to divide each of these terms by, whoops, I'm still thinking we're in the last problem here. We're going to divide each of these terms by 9. So negative 18y divided by 9 is going to give us negative 2y. And negative 27 divided by 9 is going to give us negative 3. So this piece here, this new expression after we divided by the greatest common factor, is what's going to go on the inside of the parentheses, negative 2y minus 3. And what goes on the outside is the greatest common factor itself, which is 9. Now, I also see something else that's common. I see that they're both negative. So I can actually take out a negative 1 or a negative 9, and once I take out a negative, every term inside the parentheses changes its sign. So instead of having negative 2y, we're going to have just positive 2y, and instead of minus 3, we're going to have plus 3. So either way, these two are the factored expression of the original. Okay, so I'm going to give you guys a minute to do this problem and see if you will get the same answer as I am. If you want, you can pause the video and do the problem. And if you're stuck, well, you can always obviously replay or play the video once you've thought about it and once you have your answer. All right, so let's get started. The first thing is to find the greatest common factor. So we're going to write the numbers of the terms. The first factor is going to be 1. Now I ask myself, can 8 be divided by 2? Yes. Can it be divided by 3? No. Can it be divided by 4? Yes. So I write down the 4. Can't be divided by 5, 6, or 7. And the last one it can be divided by is 8. So let's take a look at 36. It could be divided by 2. Can it be divided by 3? Yes, it can with 12. Can it be divided by 4? Yes, it can with 9. So 4 is written down. 5, no. 6, it could. 7, no. 8, no, not with 8. With 9, of course. With 12, of course. But we can stop there. The first one I see that is common, or the last one I see that's common, is the actual 4 here. There's no other 8 in the factors of 36, so 4 is the last one. Don't have to keep going with the 36. So the greatest common factor is going to be 4. So now all we have to do for step 2 is to divide the original expression by 4, by the greatest common factor. And we'll get a new one. So 8x divided by 4 is 2x, plus 36 divided by 4, which is 9. So 2x plus 9 is what goes inside the parentheses, and what goes on the outside is going to be the greatest common factor that we found, which is 4. And just to verify, 4 times 2x does give us 8x, and 4 times 9 does give us 36. So yes, this is the factored form of the original expression. All right, so let's factor the very last expression here. Factor the expression 28y minus 32. So the first thing we're going to need to do is write down the factors. So we're finding the greatest common factor here. We have 28 and 32. So the factors of 28 are obviously both of these start with 1. It can be divided by 2. It cannot be divided by 3. Can it be divided by 4? Yes. And then 7. Can it be divided by 8? No. 9? No. 10? Nope. The 14 is the next one. And then 28. And the factors of 32, can it be divided by 1? Yes. Can it be divided by 2? Yes. Can it be divided by 4? Yes. By 8? Yes. 16? Yes. And then 32. So the last one I see that's alike is the 4 itself. So let's go ahead and draw a box around them. And then step 2 is to divide by the greatest common factor. So let me write that down. I don't think I've written it for the last 3 examples, but divide by greatest common factor. And we found that to be 4. So we're dividing the original one by 4. So let me actually read it like that. Minus 32. So we're going to divide each of these terms by 4. That's going to give us 28y divided by 4, which is 7y. And 32 divided by 4, which is going to give us 8. And this is what's going to go inside of the parentheses. So we'll write the parentheses here, 7y minus 8. And what goes on the outside is going to be the greatest common factor, which we found to be 4. And just to verify, of course, we're going to multiply the 4 to the 7y and then the 4 to the negative 8. 4 times 7y is 28y, and 4 times negative 8 is negative 32. So it verifies that this expression here is the factored form of the original expression.